this building, we'll see it on the inside when we go there, but all of the apartments are heated and cooled through the ventilation air. So it's been exciting to be able to not only learn and start thinking about Passive House, but actually start implementing it and learning and relearning from our own experience. A structural steel framing system with core slab decks.
So as you're probably all aware, there are many design and technical differences between conventional construction and Passive House construction. But there are also many differences in how it is actually built on site, constructability-wise. And having completed one multi-unit residential Passive House and having 2 ongoing at the moment, these are a few points that I have found to stick out on what exactly those differences are from the contractor's point of view. Detailing is a key one. Sequencing, materials for sure, precision, and cost. These are all big players from our side of things. So, Parkdale Landing. If you aren't already, I hope by the end of tonight you will be very familiar with this building. It is a 3-story multi-purpose building with 57 residential units, 2 retail spaces, some offices, and a community kitchen, which we are in right now. It was a retrofit, so roughly half, I think it was 60%, remained, and 40% was to be brand new, which posed a challenge for meeting this Enerfit standard. And then some features that you can actually see from the Passive House end of things are we have sunshades on the outside, and we have high-performance glazing, windows, and doors. So there were initial retrofit challenges when you're working with a building that you're trying to meet such a high standard that comes with all of the issues that the existing building has. As we kind of just heard from the previous talk, retrofitting is not easy. And when you're trying to combine that with a new build, it becomes even more difficult. So right off the bat, when we were starting this project, there were a few main elements that we found to be kind of major questions we were asking at the very beginning as a whole team. The first is how to ensure airtightness with the existing brick facade. Insulating and installing the vapor barrier around these existing footings, and terminating the air vapor barrier and insulation at the ground level on the existing building side. All which are very important to meeting that airtightness, to meeting that standard, to getting a high efficient building. So this is the existing building. The left is where it was kind of more or less cut off to where the new building would start, then to meet the 3 stories. And the right is the existing facade on Parkdale, so just right out there, that's what it used to look like. There was brick, there was block, there was stucco, and they were all at different levels. They went in and out and in, so what we ended up doing is building it up with many layers of plywood to make it a flush facade. And this would soon become our layer for our air vapor barrier and our insulation, so a lot of time went into that facade to just make it more or less, straight, which it wasn't before. So with this became the challenge of how do we air seal this? How do we make sure, going from the new facade to our existing facade, that it was going to be continuous and that it was going to be airtight? So, of course, in the classic Passive House fashion, we did a mock-up. So on the existing facade, we had the installers of the blueskin, we had the blueskin rep, and we had all of our team here. What we did is we primed part of the wall, we installed a couple sheets of blueskin, and we did what was called a pull test. So we left it there for a bit, and we saw after, a couple days maybe, if we could pull it off. Fortunately, we passed. It wasn't able to get pulled off, and we found that it was sealed around all four sides, and we kind of shut down some of our worries about the uneven brick and the deteriorating mortar causing any air gaps. We kind of felt through it. It didn't seem to be any bubbles in it, so it seemed to us that it was actually adhering into the brick. So that shut down our fears, and we were ready to get going with sealing this building up. So the next big challenge was detailing, and this comes in the under-slab. So our under-slab vapor barrier and insulation, of course, is very important in meeting those comfort levels in a basement. So originally, I think what we had thought was that we'd put the vapor barrier over top of all layers of insulation. We quickly learned that this was not the right way. The mesh chairs quickly penetrated the vapor barrier. So what we learned from there is we brought a layer of insulation on top of the vapor barrier to create kind of an additional barrier to protect that product from getting punctured. On the left-hand side, you can see us taping the joints and making sure there's absolutely 0 holes in the underslab. Now, another challenge was the existing footings and how to bring that vapor barrier up these existing footings that we could not get around. So here you can see there's many folds and lots of tape, and this is more or less what happened at every single footing. Something that we did not expect to happen. We did not allow this for all the labor that was going to be used to do this kind of detail. And even after we did all this folding and taping at these existing footings, we still found that we had to do a caulking or a mask in behind because there were still air gaps where it could get underneath the vapor barrier. And then lastly is the photo with it more or less all complete before our pour. And here you can see we brought the permeator up the wall and we taped it to make sure during the concrete pour it did not move. So, it might have taken a lot more effort to get there, but we got there, and we've learned from that, and we hope to not do it again. Now, another hiccup that we found was terminating the air vapor barrier and insulation at the ground or the foundation at the existing. So we all know at new buildings, you insulate down the foundation wall, you bring your air vapor barrier down the foundation wall, you go under the slab. Now, this building sits right on the property line. That was really not an option for us. Thinking about all the sidewalk cutting, permanent sidewalk closures, we didn't really think that was going to fly with the city. And also, this building was quite old, and from demolishing some of it, we realized that. So we might have needed additional shoring if we had to dig all the way down that existing foundation wall. So it was not an option. So we had to figure out another way. So what we ended up doing is the detail on the right. And if you look at the picture on the left, you can see the insulation here, because this was unfinished. We had siding to come down. Insulation right at the top here. So what we ended up doing is digging down, putting 4 feet of insulation down, and then transferring our thermal resistive barrier to the inside. Because throughout the whole exterior building, it was on the outside, and then when it got down to this point, we wanted to transfer it to the inside, which is not 100% accurate, but it's the best way that we could in a retrofit situation. So on the interior wall, we completely spray foamed that interior wall with at least an overlap of 2 feet, which then created a harder area for that heat to escape out. It had to go, here, I'll just point right here. So this overlap of 2 feet created a harder space for that heat to transfer out. So it's the best we could kind of do on the situation that we had, and we think it's been performing pretty well so far. So we were pleased with this detail. Now the windows, of course, are always an interesting detail. So our windows sat outbound of the structure, kind of in the insulation layer, where is the sweet spot. They sat on fiberglass angles. So what we went kind of back and forth with this detail on how to exactly seal our air vapor barrier into our windows. So what we ended up doing is completely blue skinning our building. The blue skin went inside of our rough opening. Then we installed our fiberglass angles to hold our window. And then our blue skinners came back, and we blue skinned over top of the angle. Then we took our high performance tapes, taped from the face of the window to that blue skin. So yes, this detail works, and it was great, and we were confident with the air seal. Sequencing wise, our blue skinners had to come back after they had completed the entire building and do all of the windows afterwards. Taping was okay because they could come and do it, but we're always looking at ways to make a better detail. And also, we were well aware that our air seal was exposed to the outside. So we were trying to think of a way, maybe we can get that inside, which I will talk about later, how we are doing on future projects. So sequencing, this is a huge area for us. So of course, our air vapor barrier and insulation are key players in Passive House building. So we blue skinned our entire building. Then we did our air test. And then before our secondary air test, we wanted to make sure we installed all of our fiberglass clips that were to hold our siding. This became an issue for sequencing on site because we're kind of in a lull period waiting for the entire building to get fastened with these clips, which takes a very long time. There is a clip probably every 6 inches or so. and then you got to install the rails. So this was a huge learning lesson for us. We were kind of in the waiting period, which our blue skin, well, if you drove by well enough, we had a blue building for about 5 months, which if you talk to the Henry rep back there, I'm sure he will not suggest keeping your blue skin outside for 5 months in the weather. So this was something that we tried to avoid, but we did the best we could. So we went back and made sure there was any damages were fixed from the weather. It's a pretty good product, so it withheld, but we just wanted to fix those. And then also when we were doing our spray foam, we ran into almost the same thing, where if you ever stand out in the corner, right there is very windy corner, and we are right on the property line. You are right next to the cars and right next to the people. This created a waiting game as well for the spray foam, as they couldn't spray a lot of the days. It was windy, it was rainy. If there's any wind at all, the spray could, they have a certain measurement that they want to be away from getting it on the cars and people. So this also created a waiting game, which left our blue skin out even longer, of course. So you think you got over one hump, and then the next one comes, you're like, go ahead, spray foam, and then here we are just waiting for it. So these are things that we tried to see, how can we get around this next time? And then, of course, we had our air testing. First one went off without a hitch with the help of WSP. They did a great job. Second one kind of, I wouldn't say caused, but was in part of the reason why we were having sequencing issues before, because we wanted to wait for that secondary test. We wanted to have all the clips installed to make sure they weren't going to have any problems with our air barrier. Once you spray foam, you're more or less, you're stuck, right? You can't get back in there. Once you take out spray foam, you can never spray it back to the way it was before. So we wanted to be able to fix the problems should they come up on our second air test. So that's why we had to leave it open for this. And this is, I don't know if it's going to play. No. Well, that was just a little video of us going around the windows just to show. There was no air being sucked out, so our windows were pretty sealed, so we were pretty happy about that. Okay, so materials. I see lots of materials here today. So this was kind of our first kickstart for the whole team to Passive House. So this was also an introduction to a lot of new products that we were not used to using or have never heard of. Armatherm, thermal brakes, a huge player. There's also an alternative. I think it was General Plastics. We didn't end up using it, but it's comparable, I think, in some senses. Passive House certified windows and doors, another huge player. And Proclima or Siga tapes. If you were to strip off all the siding and insulation on this thing, you will see them everywhere. There's tape, and it's a huge player. So we found that suppliers or installers sometimes try to suggest an alternate. And for the most part, we found that the product spec was kind of what we needed to pass and meet those standards. So sometimes it would work, but for the most parts, we found that these are kind of areas that we don't want to skimp out on at all. These are going to make or break if we're meeting that standard or not. Another big player was the windows. So these are triple pane windows. I'm sure Veta can speak to all the technicalities, but they're heavy, very heavy. And in this building in particular, we have very large operable panes. So that was something that we were not used to. I mean, these hinges, they can only hold so much, right? So this was a huge learning curve for us. And sometimes that, cost, might seem a lot more to go to the next supplier, but what we found is communicating with the supplier and getting their contacts of who has installed their windows has been really helpful. As a team, we've reached out to see how people are enjoying these windows. How are they standing up? How are they used in a commercial, in a commercial setting? Are they withstanding the wear and tear to commercial? It's really that process that's going to help. How are they after 1 or 2 years? A spec sheet can only tell you so much. So it's that kind of process that we really try to learn on our next buildings. Taking that precaution beforehand, before just buying whatever is the cheapest. And we've all learned through this process that that's not always the best, right? In these kinds of situations. And I'm sure I'll get a lot of pushback on this one, but Passive House doors, they're essentially large windows. So if you can think about how heavy that window is and how much stress those hinges are, imagine that as a door. And interestingly enough, Beth and myself went to BC for the Passive House conference, and we got to visit BC Passive House, which is a prefabricated wall panel factory. And they have these beautiful wood triple pane passive house doors in their facility. So we were just curious, we're looking for new products. What are they? How are they standing up? They said they are rejigging them once a month, once every few weeks, constantly. And this is in in BC where they have so many products open to them for this. So it's not that it's the product, it's the commercial use of it, and how often they are getting used. So it's nice for them. They got carpenters right there, so they can fix them constantly. In a multi-residential building, I don't know if you're going to have a carpenter. Graham says no. There's not going to be a carpenter sitting here every day waiting to fix it, because you pull it tight so many times it's not going to shut anymore because it's sagging. So if you have room in your passive house model, go to the best aluminum thermally broken entrance door you can find in Ontario and see if there's room for that, because sometimes commercial differs from residential, and we're just getting into that commercial sense now. We're just experiencing that now, and these are the things we kind of figure out. It can't withstand. So precision is just a thing that I wanted to mention is different from conventional to passive house. Of course, there was a trust and a workmanship that we built with our trades, that they would be honest when they needed to go through the air vapor barrier, and that we would help them do it so that we wouldn't miss any sealing. So it was just being open with our sub-trades. So cost. So we initially started this 2016. We were thinking, we did a little bit of research, and I don't know how we came up with this, but we thought 2% increase was what it would cost to add those passive house changes to the construction. After finishing Parkdale Landing, we found it to be more around 15%. And there's a few reasons for that. One, it's our first time at this. It can only get better, right? So second, there were, as you see, as I've gone through, there have been a lot of things that we said cost a little bit more than we thought. And there are ways to reduce that. So areas that we thought were higher were, of course, that under-slab vapor barrier going over to our existing footings. We can change the foundation. You can go to a raft slab, as I'll show you in a second. And that will eliminate a lot of that labor, so that can be cut down right there. Window detail and install. We did a 4-inch fiberglass angle. We had 6 inches of spray foam. So you need a stop. So around every window, we needed to build out to make up for that extra 2 inches to stop the spray foam. So we did look at 6 inches fiberglass angle. They're more expensive because they're custom. They didn't come in that size. They were, we would have had to cut and all that kind of stuff. So maybe going to that extra cost would have been worth it. So that's another area. And then preparing the building for air testing. This is something that we weren't familiar with, so this was kind of an eye-opening experience for us. You got to seal a lot of things. There's a lot of openings in that you have to seal for your air test. So that was just, we can get better at that. We can do it as we go, maybe to eliminate that extra labor at the end. So now this is the most important part, is relationships with the architects, owners, engineers, and ourselves. Working as a team is important. Having everybody on the team open to suggestions is the best option. Not being married to any certain design. Because with Passive House and kind of construction management, we get to hear from both sides what we need and what we think is doable on site. So having everyone open to everyone's suggestions was such a good process. Understanding the big picture. Things might cost more. Items that you thought were half the price might be double now. So those types of initial shocks, you need to remind yourself we're looking at the big picture here, and we're trying to get to an energy efficient building. We're looking to overall reduce, and some areas might be cheaper, and we're happy to tell you which areas you're saving on. Well, we're also telling you which ones you're going to spend a lot more money on. So it's kind of having that team be well aware of that before, and sub-trades involvement. That is a huge key player as our sub-trades become quite inventive. You bring them into what you're trying to build, and they will help you do it. A lot of our sub-trades on this site, say there's a pipe in Passive House, you don't want to be swerving your pipes everywhere. They would come up with an alternate solution, which would still meet our standards. So it's really getting everyone involved, and it makes a lot less work for our site super to have to constantly be on people about being energy efficient. So lastly, what's next? Why the heck do we care about all this stuff that we went through? It's because we want to learn and not do it next time. These are pictures from our next building with Indwell and Houston Street Baptist Church. It's called 500 James Street. Here, we luckily did a raft slab. So our vapor barrier and insulation goes right under our footings, comes up over top of our granular and right under our slab. No more going around those footings, no more all of that tape. This is a picture here, so you can see the footings will be in here. And we're just finishing up our insulation, and we install rebar wire mesh, and we pour right on top of that. Beautiful. It was amazing. Another thing we did to the exterior here for that window detail, we are air sealing from the inside, saving our tapes from that exterior weather, giving them more of a chance to stay intact. Another thing for sequencing, that darn spray foam, we changed to Roxol on the outside. So this also is a lot more removable should there be a problem, and it allows us to install essentially in any weather. So this will get rid of that sequencing problem where we're sitting there raining every day, windy every day, that kind of thing. And also passive house doors. We made the decision with the owners and architects to find a really thermally insulated, thermally broken aluminum door and frame, instead of the passive house doors. The amount they're going to be used, they can't take the wear and tear. And we've added extra heating to the vestibule should condensation be a risk, which we've modeled it and it's not, but just precautious measures. So these are just a few ways that we're implementing all of these strategies that we've learned. And we hope to keep learning from there. I just want to say thank you to all of the team members that are here tonight. And thank you.